The table to the left gives two pieces of information for each of 15 dogs of similar breed. And for each dog, we have the two pieces of information are the average number of hours of daily exercise the dog had when it was alive and the age of the dog when it passed away. So the goal of this exercise is to, one, determine is there a relationship between these two things, and two, if there is a relationship, well, use that relationship to predict something else about this relationship. So what I want you to do, or what we're going to do, is first take this data and construct a scatter plot. Now, a scatter plot is an informal way of determining if there is a relationship between these two pieces of information. And to determine if there's a relationship, we have to determine, do we see a pattern within that scatter plot? And then we're going to, well, if we do see a pattern, then we could calculate the correlation coefficient. And if that correlation coefficient is large enough, i.e. larger than the critical value, then we can construct a linear regression equation. So I have the formulas down here. Now, if you want, now I'm not going to use these formulas in this video, but if you like, you could pause the video now, take out your handheld calculator and calculate these three values. So the correlation coefficient, the correlation coefficient goes here, the slope goes here, and the y-intercept goes here. So if you want to calculate those by hand, be my guest. It'll take about 45 minutes, and hopefully you don't make a mistake within the hundreds of individual calculations involved. So what I'm going to do is delete this for now because we're not going to use it. So we don't need these formulas. A much more efficient method is to use Excel to calculate these values. Okay, so I want to walk through in detail, walk through the steps to create the graph, calculate the correlation coefficient, come up with the regression equation, and then use the regression equation. Okay, so number one, construct a scatter plot. Now, making graphs in Excel is very, very easy. You highlight the information you want to graph, go to Insert, and just click on the little icon that looks like the graph you want. We want a scatter plot, so this looks like a little scatter plot here. It says Insert Scatter XY. Yeah, so we'll click on this and boom, there we go. We have our graph. Very, very easy. And this is the scatter plot. 15 points. Each point is coming from this pair of values. Now remember, this type of data is called matched paired data. It's two sets of the same size where there's a relationship between the sets. In this case, the two values are each coming from the same dog. And now we could see in this scatter plot, we see it looks like there's this upward trend within the data. So it looks like they're all following the same general behavior. So yes, it looks like based on the scatter plot, so number two, based on the scatter plot, does there seem to be a relationship? Yes, absolutely. So now it looks like there's a relationship. Now, to verify that there is a relationship, we need to calculate the correlation coefficient and compare it to the critical value. Okay, that is how we determine definitively if there is a statistical relationship. Okay, so I'm going to put the correlation coefficient right here. And again, remember, if you don't know the Excel function, you don't have to memorize any of these Excel functions. You just start, you start with an equal sign. You want Excel to calculate the correlation coefficient. So you type an equal sign and then just start typing the first few letters of the word of the thing you want. We want the correlation coefficient. So C-O-R. I type the first three letters and there's only one Excel function. That's it. C-O-R-R-E-L, that returns the correlation coefficient between the two data sets. That's exactly what we want. So I'll click on this, and now Excel is telling me, if you see down here, in parentheses, array 1, comma, array 2. So array in Excel, array means a list of numbers, a list of data. So array 1 is these values here, the hours. Then I'll type a comma. And now Excel wants array 2. It's this second list of values. All right, looks good. Our correlation coefficient is 0.92, about 0.925. And in the context of correlation coefficient, remember the correlation coefficient is some number between -1 and 1. It's never larger than 1, and it's never smaller than -1. And it basically, when we compare the critical value, when we compare the correlation coefficient, which is this 0.925, when we compare this to the critical value, we're basically just asking a very simple yes/no question. Is there a relationship? Yes or no? So let's say there's a critical value here, that's going to be a -1, and there's a critical value here, that's going to be a +1. So if your correlation coefficient is between these two critical values, the answer is no. But if your correlation coefficient is bigger than the positive critical value, the answer is yes. And if your correlation coefficient, the value for R, is smaller than the -1, the answer is yes. And that's how the correlation coefficient works. Now the question is, what is that critical value? The critical value is just the cutoff point. It's the cutoff point between the yes and the no. So in number 3, we compare it to the critical value to verify this. Use alpha equals 0.05. Now, alpha is the statistical significance. I don't want to talk about that now. All we need we don't need to know what alpha stands for or what it means. All we need to know is, in the table of critical values, there are 2 columns. One for alpha is 0.05 and one for alpha is 0.01. So since in this problem we're told to use alpha equals 0.05, we could ignore this column. And so now, which critical value do we use? Well, it depends on how much data we have. And we have 15 dogs, so there's 15 points or 15 pairs. So we're using 15 for N and 0.05 for alpha. So the alpha tells us the column, the 15 tells us the row, and here is our critical value. 0.514. And then there's a negative 0.514. So the answer is yes. Our value for R, which is right here, our value for R falls in this yes range. About 0.925, around to 3 places. Okay. So since the answer is yes, since the correlation coefficient for this data, the correlation coefficient is larger than the critical value for a data set of size 15, the answer is yes. So now we could take the next step, which is find the linear regression equation. Now, linear equation, y equals mx plus b. And so when you graph it, it's a straight line, and then we could put that line into so what we want to do is have a line here, and we have the equation of the line. And that line is our linear regression line. And this equation, the linear regression equation, sometimes called the predictor equation. So basically what we're going to do with this equation is take the information we know, take the data we have, and use it to create this equation which allows us to predict things that haven't happened yet based on the data, based on the things that have already happened. In the context of statistics, we call it a linear regression line. In Excel, it's called a trend line. Okay, so we basically want to insert a trend line. And so let's look at how that works. I'm going to erase what I have here in green because I want Excel to put this stuff in. Okay, now here's how it works. Select your data. So click on any one of these points, and once I click on one, you'll see they're all highlighted. Okay, so now the data is highlighted. Right click on any one of those data values, and you'll see right here, add trend line. That's what you want. Add trend line. So when you click on the add trend line, you'll see these options, and there's a line on the graph. In this topic, we're talking about linear or straight line models, but there's exponential, there's logarithmic, there's polynomial, there's power. So there's all these different models, but the most common one that we're going to see, and the only one we're going to use in this class, is linear. So there's the line. Where's the equation? Well, all you have to do is click this box. All you have to do is click this box. Now, I'm gonna bring this. I'm gonna bring this back. What I had deleted earlier. So what I'm gonna do before I do that, well, yeah, let me click this box. Display equation on chart. So by clicking that box, Excel gave us the equation. I'm just going to make that a little bit bigger by increasing the font size. All right, so there's the equation of the trend line. So what we just did was this equation and this equation, the slope and the y-intercept, these insanely complicated equations to do by hand with paper and pencil on the calculator. These two equations, Excel just did for us, just by clicking that one box that said display the equation. The slope and the y-intercept, now we have the slope, 2.88, and the y-intercept, which is 5.09. Okay, so this is why this 45-minute or so process takes only less than 60 seconds to do all three of these. So this first equation was what I typed here in this box, and these second and third equations came from clicking the box that said display the equation on the chart. Okay, so up here I'm going to put my M. I'm going to type in 2.88, and I'll type my B, my y-intercept, which is 5.9049. Okay, so now we have our scatter plot. We have the graph of our linear regression equation. We have the equation itself, the linear equation y equals mx plus b. So now, use your linear regression equation to predict how long a dog would live if it exercised on average 3.5 hours daily. So if hours is 3.5, what is the lifespan? Well, basically we have an equation, y equals mx plus b, where x and y are the variables, where these are the x values and these are the y values. So what we basically have is plug in 3.5 for x, solve for y. And that's what That's what number 5 is telling us to do. If we're given an X value, which is 3.5 hours, what is the Y value, which is the life expectancy? Okay, so we just need to plug in a 3.5 for that X right there. And we could do this using Excel very quickly. So Y equals, so I'm typing it in right here, Y equals M, which is that, times X, which is that, plus the B, which is that. So equals mx plus b, m times x plus b. And based on the 15 dogs, whose information we already know, we could use that data and the pattern inherent to that data, which is this line in this equation, to predict or estimate the lifespan of a dog that gets on average 3.5 hours of exercise per day, which is just about 16 hours. Now, if you want, we could round this, because all this data is in whole numbers. So if you want, we could round this to the whole number, and we get 16. Okay, so that about does it. It might not be a bad idea to we go back and rewatch the steps, or open up the actual Excel file that I've posted, and just see if you could work through the problem once you know how this is done. I mean, this took me 15 minutes because I did a lot of talking. But if you know, once you know how to do this on Excel, this is the entire problem, 1 through 6, should take you less than 2 minutes. It's that quick. Last question before I close the video. Do these results show that dogs that get more exercise tend to live longer, or does more exercise cause longer life? Well, the answer is no. This does not establish a cause and effect relationship, even though it probably does. Probably more exercise does cause a longer lifespan, but the correlation coefficient isn't enough to definitively say that, even though it's probably obvious. What we've done here is we've established that there is a relationship. Now, if you wanted to then determine if more exercise definitively caused longer lifespan, you would have to do a little bit more research. But this is an indication. This yes right here, this yes is an indication that, yes, more research should be done to determine if it is a cause and effect relationship. But remember, correlation does not imply causality. Okay, that about does it for this video.